Today I'd just like to take a quick look with you about some of the storage and moving instructions that we have in MIPS. We've already seen some of them, like load word, when you want to load a word from memory into a register. We've seen load immediate for loading hard-coded values into certain registers or addresses. But today I'd like to have a look at some of the other ones, as well as how we might use actual hexadecimal values when we're loading in numbers. Okay, so let's have a look at load immediate. We know that that takes a register, so let's just say A0 for the sake of simplicity. I want to give it a hexadecimal number today, or a word. And the way that we do that in MIPS is that we start off with 0x, that lets us know that it's a word, and then we go for 0, 0, and we're going to use the word coffee today. Okay, so that's a 32-bit word, and that should load the hard-coded value of coffee into register A0. Now, what about store word? Well, store word allows us to store the contents of a register at any unreserved memory address. Now, you might remember from one of the previous lectures that some parts of MIPS memory are reserved, but some of them aren't. Some of them we can use. And as you know, MIPS has 2 to the 32 different memory addresses, so there's quite a lot that aren't represented by our basic registers over on the right here that we might want to use to get access to more memory. So let's say we want to store what's in register A0, and I'm going to give it the address 0, 1, 0, 0, 1, 0, 0, 0, 0. Now, this is just an arbitrary address that I happen to know is free. It's not reserved for the kernel or the program text or anything like that, and it's also the first line that shows up when you assemble your code, so it'll be easy for me to show. That's the only reason I picked this address. But it is worth noting that you should be wary of the addresses that you're trying to access when you're writing MIPS code. For example, 004 followed by 5 zeros is the program text, so if you try and store something there, you'll get an error at runtime because you try to overwrite the program text with your code. So let's have a look at move. This allows us to move values between registers. Now that might be handy if, say, you're performing a calculation over and over again, you don't know when it's going to be done, but you want to print it at the end, so you can store it in another temporary register like T0, and then you can move it over to A0 so that you can print it out. Or you could just want to change things at different addresses, overwrite things, that sort of thing. And that's what move does. Lets us change, take the value stored at one register, store it in another. And the way that we do that, let's say T0, we're going to store the value at A0 in there. So let's compile this. Luckily we've managed to compile successfully, and let's run it and see if everything that we expected to happen happened. So it's finished, it's dropped off the bottom. That's because it's gone past the end of the memory address and memory without us ending the program. So let's have a look and see what's happened. We can see A0 does in fact have coffee in it, so that's good. And we can see that T0 does as well because we moved A0 into T0. You'll notice this just copies, it doesn't overwrite what's in A0, so that's handy. And if we come over here and look in the data segment, you can see that this is the address I was talking about earlier, and it does in fact have coffee. So you've got all of these addresses here that you have access to, so you might need to use them at some point in the future. But that's everything I wanted to talk about today. This is just a short and sweet video. In one of the upcoming videos, we'll be looking at a more in-depth analysis of memory registers, how we access them, and a little brush up on endianness of different architectures. Thanks.